Hello, let's look at our first problem. Verify by substitution that y is a solution of the differential equation. So we have our proposed solution y, which is 3e to the negative 2x, and we need to see if it solves the differential equation y prime plus 2y equals 0. Now we already have the equation y given here, so we'll just substitute this in for y. But we do need to determine off to the side what is y prime so that we can substitute that as well. So y prime, we know the derivative of 3e to the negative 2x is here. Bring down the inside function by chain rule. So our first derivative simplifies to negative 6e to the negative 2x. And we're going to substitute these into our equation. So we have negative 6e to the negative 2x plus 2 times 3e to the negative 2x. And if our given y is a solution to the differential equation, we will get the final statement that when we substitute in y and its derivative into this differential equation, we should get 0 as a result. And indeed we do, because this is negative 6e to the negative 2x. This is 6e to the negative 2x, so we have negative something plus positive of the exact same thing will indeed equal 0. So we've shown that the given y is a solution to the differential equation. In our next problem, we will substitute y equal e to the rx into this differential equation, and from that we need to determine all values of the constant r that would make y equal e to the rx a solution to the differential equation. So all values of r that make the differential equation true. Now as we look through this problem, we see that we need to find the original y which we are given, that is e to the rx, its derivative, and its second derivative so that we can plug it into the differential equation. We know the derivative of e to the rx is r e to the rx. Take the derivative again and the constant r comes down and we get r squared e to the rx. Next we substitute this into our differential equation, and now we solve to see which value of r makes this equation true. The first thing that we might note is that this e to the rx term appears in all three, so we can factor that out to the front. And we get e to the rx times 3r squared plus 3r minus 4 equal to 0. And now it comes down to an algebra problem. The way we need to envision this is, remember, if you ever have something times something equaling 0, that can only happen if the things ever separately equal 0 by the zero product property. So we need to consider, when is this equal to 0 and when is this equal to 0 separately. Now if we know our graph of e to the some value of r, some constant x, we know that that equation will never equal 0. So this never equals 0, thus it contributes no solution here. So we'll focus here and we'll ask ourselves, when is this quadratic equation equal to 0? Now looking at it, we might be able to think that we won't get much help through factoring this, so instead we turn quickly to the quadratic equation. And we know our solution will be when r is equal to negative b, taking from our b, plus or minus the square root of b squared minus 4ac all over 2a. And as we simplify that, we get negative 3 plus or minus 3 squared is 9, minus a negative 48 will combine to be a positive 57 all over 6. So the values of r that make this a solution to the differential equation are these two. Now in our final problem, we will verify that this is a solution to the differential equation. And after we've done that, we will use this initial value to determine exactly what value of c solves the initial value problem. So first up, to verify that this is a solution, we know that the differential equation involves the derivative being equal to twice the original. So we take the derivative. The constant is there. The derivative e to the 2x is e to the 2x times 2. So this cleans up to be 2c e to the 2x. And now let's verify. We know that the derivative should be equal to twice the original. Now our original is c to the 2x, and we see that that is indeed true. So we verify that this is a solution of the differential equation. Now specifically, our solution should meet the condition that if we input 0 into x, which would have us inputting our 0 here, then the final result should be 3. So that gives us 3 is equal to c e to the 2, 0. 2 times 0 is 0. E to the 0 is 1. So this becomes 3 equals c times 1, which tells us c should be equal to 3 in this case. So our specific solution is 3e to the 2x.